Hi, my name is Tom Woodward, and I'd like to welcome you to a conversation with Michael Behe, part of the Princeton video series. Dr. Behe, a professor of biochemistry at Lehigh University in Bethlehem, Pennsylvania, triggered a cultural earthquake when his book Darwin's Black Box appeared in 1996. In his book, Dr. Behe argues that his own area of research, the study of molecular machinery and tiny subcellular systems, lends no support for the claims of Darwinian evolution. Rather, says Behe, these biochemical systems, such as the whip-like cilia with which many cells are equipped, involve so many working parts, all of which are necessary for function, that no gradualistic theory fits at all. Indeed, says Dr. Behe, if you search the technical literature for attempts to explain the evolution of these systems, you are greeted by a thundering silence. Dr. Behe argues that due to the irreducible complexity of these systems, an intelligent designer is clearly indicated. Michael Behe is a Roman Catholic who says that he was always taught that God worked through evolution. Therefore, his religious views, says Dr. Behe, have nothing to do with his change of mind. Rather, he says it is the force of scientific evidence which has led him to propose intelligent design as a vastly superior explanation for the complexity inside the cell. The public has heard of Darwin's Black Box through coverage in the New York Times Book Review, and the Times has even published Behe's own summary of his views in an op-ed piece called Darwin Under the Microscope. I spoke with Dr. Behe in his research lab at Lehigh just before he lectured at Princeton University. Here are some highlights of that conversation. I'm at Lehigh University in Bethlehem, Pennsylvania, in the biochemistry lab of Dr. Michael Behe, who teaches in the biology department at Lehigh University. Dr. Michael Behe, thank you for letting us come into your lab and invade your territory. Looks like we're surrounded by reagents and chemical bottles and heavy-duty equipment. What do you do in this lab?
Well, I'm a biochemist interested in nucleic acid structure. Most people know the story of Watson and Crick from the early 1950s discovering the structure of DNA, but in the past 40 years we've also discovered DNA can do some other tricks besides just being a double helix, and we investigate those tricks.
Sounds fascinating.
Yeah, we have fun.
That's great. Well, speaking of tricks, your book, Darwin's Black Box, which I think is somewhere around its 15th printing, one of the things that people spot when they see your book in a bookstore is that striking picture of a black box that's being opened up and white light coming out from it. What do you mean when you say Darwin's Black Box?
Well, a black box is a term we use in science to mean some system that does something, but you don't know how it works. Mm-hmm. And a good example for most people of a black box is a computer. And people use them to write or to draw or something. Most people don't know how they work. And to Darwin, the cell, which we now know to be the basis of life, the cell was a black box. Scientists of that time, of Darwin's time, knew that the cell could grow and could make things, but they hadn't the foggiest idea how it worked. And because of that, many scientists of the 19th century thought that the cell was simple. And a scientist named Ernst Haeckel called it a simple glob of protoplasm, kind of like a little piece of jello. Mm-hmm. And in the past 50 years, science has advanced so much that we've been able to open the black box of the cell. And what we see inside is not simplicity. We see enormous complexity, complexity that was completely unexpected by previous generations of scientists.
In your book, you have brought out and taught us all this new phrase, irreducible complexity. And then you've said this is a problem for Darwin and Darwin's theory. Explain this interesting phrase, irreducible complexity. Yes. Help us with that, and how does it confront a problem or present a problem to Darwin?
Well, irreducible complexity is just a fancy phrase for a simple idea. It just means a system or an apparatus that contains a number of parts, and all of those parts are needed for the function of the apparatus. And a simple example is a mousetrap. A mousetrap has a platform and a spring and something called the hammer and the holding bar and a little catch for the holding bar to fit into, and all those parts are necessary for the mousetrap to work. In the absence of them, then you don't catch any mice, you have a broken mousetrap. And the irreducible complexity is pertinent to evolution because in The Origin of Species, Darwin said if it could be shown that any biological organ or system existed which could not possibly be made by numerous successive slight modifications, my theory would absolutely break down. Now, an irreducibly complex system can't be made by these numerous successive slight modifications because it doesn't work until it's essentially complete. You can't have a wooden platform and catch mice inefficiently and add a spring and catch them more efficiently. You don't catch them at all. And in the cell, we've seen in the past 30, 40 years, the cell is just chock full of irreducibly complex systems. There are molecular machines in the cell, literally molecular machines that make it work. And many of them, just like machines we see in our everyday life, need a number of parts to work.
In your book, you talk about a little structure called the flagellum. Tell us about the evidence that you found in the flagellum that points to intelligent design.
A flagellum is literally an outboard motor that bacteria use to swim through liquids. And again, it's literally, it's not an analogy. The flagellum has a propeller, and the propeller is hooked onto a motor by something called hook protein. Essentially, it's the nut that holds it on. And the motor which turns the flagellum is powered by a rotary motor, one of two that are known in nature. The motor uses a flow of acid from the inside of the bacteria to the outside to power this turning. And there's a part called the stator, which keeps the whole machine in place while it's turning in the cell. And altogether, genetic studies have shown that 50 different protein parts are required for the flagellum to work. The flagellum is a really magnificent example of irreducible complexity, of a molecular machine, and of the argument for intelligent design. When people see pictures of this thing, they immediately comprehend that, yes, this is a machine, and that it's an explanation for its gradual development by a Darwinian process is simply incoherent. And if you look again in the scientific literature, no scientist has even tried to explain how such a thing could have been produced by Darwinian evolution.
Is it true, Dr. Behe, that the origin of life problem is solved? It's pretty well in hand, like we're often told in textbooks, or is it a medium-sized problem, or is it even a big problem? How do you see the origin of life?
The origin of life is a fundamental, massive problem for any naturalistic explanation for life. And this is unlike Darwinian evolution. After life has got here, many scientists will speculate that Darwinian evolution can explain life once it's here, but you can't have Darwinian evolution before you have life. And so you have to imagine an enormously complex entity, the cell, coming together by some chance process. And you can find many scientists who are willing to say, we haven't the foggiest idea how that could appear, or how the cell could appear. It is a major problem. A man named Franklin Harold wrote a year ago in a journal called Microbiology that the problem of the origin of life is utterly beyond our comprehension. And because of that, it makes a person a little bit angry to see how the question of the origin of life is treated in high school biology textbooks and other tracks aimed at students who don't know better. Many of these books treat it as a problem that's almost solved. We have so many good ideas, and that's utterly false. And it's completely opposite to what professional scientists think. And when I see such things in textbooks, again, it makes me angry, and it makes you want to go out there and fight to see things changed.
Tell me about the cilium, that little structure that a lot of cells have wiggling on their surface. What is it, and how does it point to intelligent design?
Well, a cilium is a little hair-like structure on the surface of many cells. And it goes back and forth like this. And this back and forth motion can either allow a cell to swim through liquid, or if the cell is stationary, it pushes liquid over the top of it. and that has a number of useful functions for the organism. And to look at it just in pictures, it looks pretty simple, a little hair, but biochemical analysis over the past 20 years or so shows that the cilium is an enormously complex machine. And how it functions is that there are a number of fibers, essentially strands, like this. And connecting the strands are a couple of different pieces. One is called a motor protein, which attaches to one strand, reaches over to the other strand, grabs onto it, and pushes it down. Now, if that's all there was, the strands would just kind of fall apart as the motor protein pushed them. But there's another piece too, another kind of like a spring called nexin, which connects the two strands. And as the motor protein pushes down, the nexin, the linker, becomes taut. And as the motor protein pushes more and more, it starts to strain. And as it goes further, it starts the cilium to bend. And then the motor protein pushes the other way, and it bends back and forth and back and forth like that. And it turns out then that the cilium is irreducibly complex. If any of those parts were missing, you would not get this bending motion. You would not get the cilium acting like the ore that it does in biological systems. If you look in the scientific literature, nobody has a clue how Darwinian gradual evolution could build up something as complex as the cilium. And I argue in my book that a better explanation, because of its irreducible complexity, because of its interaction of parts, is that the cilium was intentionally designed.
Following on to that point we're making, you have said that if these systems we find in the cell are irreducible complex, that poses a problem for Darwin. In your book, did you not say something about going and checking into the literature and finding something interesting that was going on about these irreducibly complex systems and whether there were explanations for them out there?
Yes. Whenever scientists do experiments or try to explain something, they publish their results in scientific journals, in things like the Journal of Molecular Biology or the Proceedings of the National Academy of Sciences or other science journals. And so the whole scientific community can read of what they have accomplished. So when a scientist wants to know if a question has already been answered, the thing to do is to go to the library and look to see if somebody has explained it. Well, when I became skeptical about evolution, I went to the library to see who had explained how these irreducibly complex molecular machines might have been built up by a step-by-step gradual Darwinian process. And much to my surprise, I found out that nobody had. If you look for papers explaining how molecular machines could be put together, there are very few that even try to explain them, and the few that do exist do so in such broad terms that they cannot be tested. And so I came quickly to the conclusion that not only did I not understand how Darwinian evolution could produce machines in the cell, but no scientist in the world understood.
In reading your book, it's my understanding that you're saying not only does Darwinian theory fail to explain these systems that you're writing about, but that intelligent design is clearly indicated. Is that your key argument?
That's correct. I think when you examine these molecular machines, an immediate hypothesis that pops right out is that these machines were designed. Just like you walk down the road and you see machines, you know those were designed. You can conclude that these machines were designed. Many people have accused me, because I'm a Christian, of injecting my religious beliefs into this conclusion, but I don't think it's a religious conclusion at all. It's a completely empirical conclusion based simply on the physical evidence. Let me give you an example. Suppose you were walking with a friend in the woods, and all of a sudden your friend was pulled up by his ankle, a vine wrapped around his ankle and left dangling about 10 feet in the air. And you pull him down and you reconstruct the trap. You see that a branch was pulled down and staked into the ground by another branch, and that the vine was covered over by leaves. And you would immediately conclude, based on the interaction of those parts of the system, that that was no accident. That was a designed trap. And so you can conclude intelligent design when you see a number of parts interacting with each other to give you some effect that none of the parts by themselves is able to do. And that's what you see in these molecular machines, a number of parts interacting with each other to give you an effect that none of them by themselves can do. That immediately points to intelligent design, and I don't think we should shrink from that conclusion.
You mentioned the word skeptical. How did you become skeptical of Darwin's theory?
Well, I believed Darwinian evolution all through my graduate studies and early tenure as a professor. And I believed it simply because that's what I was taught. My professors, when I was in school, taught me that Darwinian evolution was true. I didn't have any particular reason to doubt it. I didn't pay much attention to it. Almost all scientists almost all working scientists do not use evolution in their work and don't pay much attention to it. But I then saw a new book that was published at the time. It was called Evolution, a Theory in Crisis by an Australian scientist named Michael Behe. And in his book, he showed that there were a lot of very difficult problems for Darwinian evolution, which I had never thought of, and which nobody in all of my studies leading to my PhD had bothered to mention. And I immediately recognized that they were difficult problems, and I became angry that nobody had brought these up, and I felt like I was being led down the garden path to a conclusion that didn't really have the evidential support that I thought it had. And so from that point onward, I became very interested in the question of evolution.
How do you describe the overall response to your book? Your critics, both the ones that liked your book and the ones that didn't like it.
The response has been what we call in science bimodal. That is, there are two distinct groups. You hate it or you love it. And first of all, I've been surprised by the amount of response. The book has been reviewed by 50 or more magazines and journals. And the measure of attention that a book has gotten is the number of reviews that have been written about it. And within those, a number of people have applauded it, a number have not. The scientists who have reviewed the book, almost all of them admit that the problems I cite are very serious problems for Darwinism. But not many of those scientists have signed on to the idea of intelligent design, which I argue for in the book. And they don't do it because they see scientific reasons against it. Rather, they seem to have philosophical problems with the idea of intelligent design. That is, they just don't think science should postulate an intelligent designer. And my response to that is, well, science, I was always taught, should follow the evidence wherever it leads. And if the evidence points strongly to design, then it's really a shirking of our duty, a shirking of our responsibility as scientists not to follow where the evidence leads.
Tell us a little bit about the New York Times reviewing, interacting with your book. How did that come about?
Well, my book had come out in the end of July, and about a week or two after it came out, my editor gave me a call and said, "Hold on to your hat. The New York Times is going to review your book in a week from Sunday." And boy, that put me, on pins and needles. And the New York Times is oftentimes regarded as a liberal newspaper, and intelligent design is, for some reason, ascribed to a conservative position. And so I was apprehensive. But when the review came out, it was surprisingly good. The reviewer said that the book was very well written, that it describes very complex problems, that in fact we do not know how blood clotting and intracellular transport and all these other intricate machines, intricate systems we've discovered could have come about. And so his only reservation was, again, a philosophical one. he said we should not conclude design because perhaps our children or grandchildren might figure out how these systems were put together by unintelligent processes. And I don't care for that conclusion because this is intelligent design is the conclusion to which we are pointed now. And it's kind of a I think a dereliction of a scientist's responsibility to hope that a more preferred hypothesis would come along in the future rather than the one that the evidence points to right now. So I was very pleased with that, and I'd give the review an 8 on a scale of 1 to 10.
I understand that after your book came out, some pretty key people in the New York Times took note of your book and then contacted you. Is that true?
Yes. The editorial page editor, to my surprise, called me up one day and said that she was interested in my writing an opinion piece for the New York Times editorial page based on my book. And she spoke that in the past year or so they had several other scientists writing, and some from non-religious perspectives, and they wanted a scientist who was a Christian who did have a religious perspective. And so I wrote the piece, which was essentially a short summary of my book, and I sent it to them, and they said thank you, and I waited and I waited, and it wasn't being published, and I was starting to get a little bit nervous that it might be filed, but the editor explained it was an election year, they had other things to talk about, but still I was worried. But at the end of October, a news event came around which affected this, and that was Pope John Paul issued a letter on the subject of evolution to the Pontifical Academy of Sciences, a letter which I might add was widely misinterpreted. But suddenly evolution was in the news, and evolution and religion too. And so my opinion piece was timely now. And so the editor called me back and said they were going to run it in a couple days, and within 2 days the New York Times ran an opinion piece in which it was argued that life is intelligently designed.
Your book seems to have really struck a responsive chord with not only in the country, all of America seems to be talking about it, but even other countries are vying for the chance to translate it into their language. Why do you think it's selling so well? What's going on here?
Well, of course, evolution is important to us because it kind of impinges on what we think of ourselves. Are we the result of mindless processes, kind of a random collation of atoms that by chance happen to acquire the ability to think? Or are we planned? Are we the result of foresight, of a being more powerful than us, of processes that were conceived long ago? That, of course, goes to the heart of our identity. And for the longest time, science's answer was, well, tentatively we think Darwinian evolution is the answer. And many scientists portrayed that as a completely mindless process, incompatible with Christian worldview. But now, the scientific revolution in biology in the past 20 years or so has shown that that's an increasingly untenable position to hold. And for some reason, my book is the first one to point this out at the molecular level. And I think many people had been suspicious that the proponents of Darwinian evolution were too easily making up stories of how complex structures came to be. And when they saw a scientist in his own field arguing that, in fact, Darwinism cannot explain these things and that a better explanation is intelligent design, a lot of people felt encouraged by that their good intuitions were finally being supported by professional science.
There is a law professor, Phil Johnson, who teaches at the University of California at Berkeley, who has made quite a series of statements in this debate over Darwinian evolution. But he's a law professor, and he's not a biochemist like you are. Do you think he's on the right track? What do you see his key arguments to be, and do you agree with him?
Well, Phil Johnson is a law professor. There's no getting around that. And I greatly admire him. He's brought a wonderful clarity to this debate. As he points out, the subject of evolution is so broad, ranging from molecules to fossils to everything in between, that there is no person who can be a technical expert in the whole field. But it's all pinned together by logic, just as all of our human arguments are. And that his discipline is professionally interested in analyzing arguments, and especially the logic of arguments. And he brings that logic to bear with great effect on evolutionary arguments. And what he has shown in his books is that many of the arguments for evolution arise from a presupposition, and the presupposition is materialism. And materialism is not science, it's a philosophy. And it's a philosophy that says that all that exists is matter and motion. And therefore there is no intelligent designer to get life started and to keep it on its way. And so something like Darwinian evolution simply has to be true by definition. And Phil Johnson has pointed out that if you do not have reason to agree with that premise, the premise of materialism, then the actual scientific evidence for evolution looks pretty unconvincing. And so I think Phil Johnson has done really yeoman's service in getting this issue out before the public, showing them that, that evolution is not inevitable from a scientific point of view, but it only seems to become inevitable if you buy into the philosophical presupposition.